is to choose one experiment that you have to write. It's not like the essay where you actually, the syllabus says you have a choice.
No, I was spending too much time on the other experiment.
No, it is inefficient. I agree with you. I do agree with you, but I suppose it's a bit like the essay. I also think the essay was inefficient, but that's what the syllabus wants me to do, so that's what I have to do. I know. Because the syllabus requires you to do a minimum of 4 experiments. Now the syllabus actually says 4 to 6 experiments, so the best I can do is choose 4. I can't choose 1. Okay, anyways, let's just put that aside for a moment. Okay, so the first experiment you'll be doing, get rid of this, is Snells Law. So before I take out the equipment, let me just, well, we all know, you all know Snells Law? What law is Snells Law? Yeah, what's the formula?
Sine theta 1 sine r over sine I 2.
Yeah, it depends on the letters that you're using, but if you use I and or, yeah, equals, so can you see? There's I, there's or, and this material is N1 and this material is N2. So for this experiment you're going to be looking at air and water. Okay, and Snell says sine I over sine or equals N2 over N1. Takes a lot of brain power to remember that the other way. So how can we do this as an experiment? Well, the idea behind this experiment is you have a light gate, a light box, and it's the laser light is on a big wheel, and you can turn the wheel, and you can measure the angle. It's marked on the top of the wheel, and you can measure the angle here. So you can collect values of I and or. So using this, we can make a table. We can have I and we can have or. But it's not the I and the or that we care about, but rather the sine I and the sine or. So after you measure the I and the or, the next thing you need to do is sine I and sine or. Yeah? But now that you have sine I and sine or, what useful graph could you make with this? So how should you graph this?
Sine I over sine R over sine I.
Well, which is which?
Sine I is
you see, you should put sine I here, and sine or should go here. So when you graph this, what do you get? You'll get, you get a straight line. You should get a straight line. You can say sine or equals N1 over N2 sine I. So you basically get y equals mx. So that means the slope here, the gradient, is N1 over N2. But if you know that N1 is 1 because it's air, then you can get this useful result that N2 will be 1 over M. So using the table and the graph, we can get the N2 for water. And we can be quite accurate because we're going to be using many points. Now, we should start at 0 and then go up in tens, etc. You got the basic idea? Now, when you start this experiment, you'll notice that there's a a small problem, because you're dealing with water, what will happen is this will actually wobble a little bit because it's going through the water. So what you really need to include on your table is this, something which we will talk about but we haven't talked about just yet, something called the uncertainty. It's an error, yeah. So the error on the I should be quite small and the error on the or is quite big. If this is air, then this isn't really moving. So you should be quite accurate, but you're never 100% accurate. So what would be the cause of the error when you're trying to read the I? So let's say you say I is 10 degrees. Well, it's not exactly 10. You know it's not 10 exactly. It could be 10.1, it could be 10.01. There's an error. How wrong could you be? That's what the uncertainty is. How wrong you could be in your measurement. So what do you think that might be for measuring the I? And think about your protractor for measuring angles. You see, you could be off by... No, you wouldn't be that accurate. 0.01. Yeah, but why 0.5? You could be off by half a degree. Why?
Because parallel error. I mean, why?
You keep going on about parallax error throughout this whole program. And I don't think I've yet said correct. It is no. Okay, maybe a little bit, but what's the main cause for this?
Ice problem.
Yeah. Yeah. Yes, it's to do with the gaps, because when you measure an angle, let's say this is marked at 10 degrees and this one here is marked at 11 degrees. And your laser light is shining down through it, and it'll be like this thick. You know, you can't quite tell if you're exactly on the 10, or maybe only part of the light is on the 10. And because it's only marked at 11 and 10, and it's not subdivided, you can't actually know if it's 10.1 or 10.2. In other words, the error in measuring the angle, and we'll do this in a later class, it's half the smallest reading you can make. So if the smallest you can measure is 1 degree, then your error could be as much as half a degree, because you could be this much off. Do you get what I'm saying? So for this one here, the I could be half a degree, but the or is a bit different, because the or is jumping. Maybe it's jumping between 10 degrees and 12 degrees. So what's the error here? 1. Not quite 1. What value should we use? We should use 11. Because that's the average, the middle of the two. We should use 11. But what should we report in our table? What should we report as the uncertainty, the error? How wrong could we be?
0.5.
Well, think about it. If I said it goes between 10 and 12, then it's 11 is what we said the I is, plus or minus. So what number goes here?
0.5.
It could be 1.5. Yeah, well, because this could be actually as much as 12.4999. And this could actually be as little as 9.5000. And we could still read it as 10, and we could still read this as 12, because it would still round to 10 and 12, because you can only mark 1 degree. So we could be as wrong as 12.5. So 11 to 12.5 is 1.5. So the error here is actually 1.5 degrees. In other words, the error is the absolute maximum value minus the minimum value over 2. But remember, just because I saw it hit 12 doesn't mean the maximum is 12. The maximum could have been 12 and a half nearly. Yeah? Oh, because if it did hit 13, I would see it as hitting 13 because 13 is marked on the protractor for measuring the angles. Yeah.
So which value do we use?
The middle, 11 is the value you would use
To apply sine I.
Yeah, you would use sine 10 and sine 11. Now, can I scroll down? So basically what we're talking about in our first experiment, which will be an idea in all the experiments, is in physics, chemistry and biology, you have this idea. You have x, which is something that you measure, but also with the x goes an uncertainty. How uncertain you are on x. And this is what you measure. Now, if there's so can you all listen? This is the most important thing about the labs. Listen. We're going to be doing 4 hours of preparation, 4 hours of labs, and then 4 hours of writing about the labs. In those 12 hours, if you only learn one thing, it's this. I want you to know that in physics, when you have a measurement, unless you have the uncertainty with the measurement, it's useless. Okay? If you only learn one thing in the physics labs over the next 12 hours, it's this. I would like you to all definitely know in physics, unless you have this and this, then it's no good. If I only had this, that's worthless, useless. Okay? In physics, we need to have uncertainties with our measurements because we can't know how good or bad our calculations are without this. You know? If I said to you, how much money does he have? And I said, oh, he has €1 million, plus or minus €1 million. That's a big difference to if I said, he has €1,000, plus or minus €1. Now, if he has €1,000 plus or minus 1, then you know, okay, he's close to 1,000, maybe 999 or 1,001. But if I said he has $1 million plus or minus $1 million, you could have nothing, or you could have 2 million. So, how should I know if I should rob him? There's a chance that he has nothing, or there's a chance he has 2 million. So, at least this guy has 1,000, I can get that. You know. So, if that's the only thing you learn over the next 12 hours, then that's actually a good thing. Because you're all going to be doing engineering, so it is an important lesson. Okay, so now that we talked a bit about the table, the other thing that you need to have in your table, where's it gone? And I might have said this, but if I didn't, I'll say it again. When you make a graph, this is the format you use, okay? You write X with a slash and then the units. So for example, that could be X in meters. The same goes on the Y slash units. But I think you know that already. But the same is true for the table. At the top, we should have I slash the unit, because there's different units to measure angles. So what unit would we be using? We'd be using degrees, so degree. Now, we don't have to write the slash. I mean, it looks a bit silly. A lot of times you just would write I with a degree symbol here. But for all the units, you would put the slash in. So like, for example, you could have X slash meters. Yeah. Now, those disgusting biology students, they would do it like this. They would write X and then they put the unit in brackets.
Oh, that was good.
Oh, no.
I like to do that too.
No. And also what's worse is they don't write this, they would write this.
Oh, this is
Yeah. This is quite bad. Quite bad.
Teacher,
Yeah.
where's the unit for sine I?
Sine I has no unit. Now if you think about why sine I has no unit, because remember the definition of sine is opposite over hypotenuse, and these are lengths of a triangle, which would be metre over metre, or a length over a length. So sine is actually unit free. So no units, so there's no need to put in the units. So you would just write sine I. Yeah. Oh, here. Oh, look. No, in the graph that you need to make, there are no units. This is sine I and this is sine or. Now, I think it'd be a good idea to put the degree symbol on the I and the or. But I mean, that would be normal. Yeah, no, that would be normal. So you should put the degree symbol on the I and the or. But if you want to be extra clear, you can write it like this: sine I degrees, sine or degrees, to be extra clear. Yeah? Okay, are we clear on the first experiment? So we'll do this first experiment together. Who lives in this building? Lee, you're near to the door, so come over here. Lee!
Yeah. Well, what do you do?
Just calm yourself down.
Can I play with that? In my room.
I haven't even started yet and you're acting like children. Fill this up with water to the halfway line here. So exactly half water, please.
Exactly.
Water. I don't want to come back with Coca-Cola in it or something.
Oh, I have cola, do you want?
No, I don't. Don't break it.
Yeah, not all of them you write, because we only write one kind of.
Yeah, but you have to make a handwritten lab book that you must return to me. No, I told you to write this down at the start.
No,
you see, what happened was... No, don't give me that. What happened was you thought, Stephen, I've got a better idea. I shouldn't listen to my teacher. He told me to write this down, but I'll do my own thing. You should have listened to what I said. How are you supposed to read this? It's a mess. You're here early.
I just want to, see how the telly's going.
Great. We're preparing the students for the lab, so Lee has gone off to get some water because we're going to do the refraction with the little laser.
Oh.
Yeah. Can you see that, guys? So we'll put this in the water for it, yeah.
Nice.
Yes.
Was that fake? You can really do this.
I don't know. I don't know. Yeah, so we're going to try and do the labs next week or maybe this week. So we're going to do the 4 of them in class.
That's right.
So that when they do it, they don't break anything. Yeah. Anyways, you want to talk to them?
Just very briefly, yeah.
Yes. No problem. We're actually just waiting for Lee to come back because he's going to fill up the tank with water to use with this. So, yeah.
Lovely.
You want to talk to them?
Yes. No, to you.
Oh, to me? Oh, all right. All right, don't go anywhere. Yeah, I'm in trouble.
Every day it was like, how would you cancel like that? Oh, we're a ball. I really like this.
What's taking Lee so long? You just have to get water.
He's living for school.
So,
I live in second floor.
Good job.
sorry KJ, here you go. What? No, it doesn't. Actually, it's... Guys, for this one here, guys, check it out. This protractor here doesn't go up in ones. It goes up in fives. Yeah, look. 0, 5, 10, 15, 20, 25, 30. So your error for your eye is 5 degrees.
Five?
Oh, sorry, 2.5, sorry, yeah. 2.5 degrees. Which is, you know, significant and worth noting. Safety warning, please don't put the laser in your eye.
Why?
Let's do the
What is
experiment
that
about
frequency?
It's red light, or whatever that is, about
Red
650 nano,
700
700 nanometers. No, because if it's infrared, you wouldn't be able to see it. It's good old-fashioned red light.
Is
Can I
it?
actually point with this? Oh yeah, I can. Yeah.
Strength is more strong, right?
Huh?
Strength, like it's
It has no a laser. Yeah, but laser works on some kind of a different principle. The color, in fact, the color is not too important for the laser. It's the way they put all the photons together that makes the laser powerful. Something which sadly is not on the course,
The fish suit.
even though it's pretty cool. Ah, you're a sick man.
The fish suit. Because I'm gonna eat fish. This is like the best suit ever.
Have you tried these sweets?
Yeah.
And you like them?
I even tried them before.
No.
I even tried it.
Korean taste candy?
Do you know these sweets?
Yeah. Have you ever
Do you
tried
know
durian
them?
before?
They taste like fish.
Wow.
But
Anyway.
you like the fruit durian?
The real food durian.
Yeah.
Which one was that?
What is that?
Why did I try that?
Kind of
Oh, I can smell it already.
Oh, the fruit.
Oh, I
I
like
don't know if I like it.
It depends.
I don't know. I've had bad experience with Malaysian
Some
food.
people like it, some people
Like-
don't.
Yeah.
Yeah,
The
sure.
Malaysian coffee wasn't nice.
Oh my
The
god.
fish sweets weren't nice.
Yeah, I want the fruit.
Yeah, they have durian in Korea.
I'm trying to think. Have I ever tried
No,
something
yeah,
Malaysian that I did like?
Usually it's that's not from your
Still waiting.
Yeah.
All right.
Taiwan and
Are we looking?
Ah, now we are smelling.
Right. Are we looking?
Yeah.
Yeah. So what we're going to do, first we turn the laser on, and we can see that we can measure the eye, which I have set it to 0, so it goes straight down. So we don't care about the 0 one really. But if I put it to 10,
Yours. That's a different. Wow. Let's go to 50.
So can I snap it?
Yes, you can.
I'm gonna die. Three more. What's wrong with you? Wow.
This is just like a 10-euro laser and a bucket of water. That's all it really is.
Living, that smells so strong, man.
Oh my god, it's so good. It's so good.
Disgusting.
You can smell it.
It is Asian fruit.
I can smell nearly. I'm not closer.
Lee, be considerate of your classmates. They don't want to smell your fish sweets. Alright, can I continue? So, if we increase it then to 20, we get the I and the or, and so on. And we'll just continue all the way.
Critical angle.
Let's do the
That's the next half.
We can't get critical.
Hang on.
let's do the
Yes, now the next half of this experiment is to get the critical angle. So you need to do this twice, but then do it from water to air.
Oh.
So this one is the water and this one is the air.
Yeah.
Yeah, now that's different because then you can also get a critical angle, right?
Do it.
Oh wait, hang on. 20, 30, about 40 something, isn't it? 40.
Oh yeah.
No, leave it. Don't come.
Oh.
Nice.
So
Why am I
overall.
thinking? This smells so good, guys.
Ah.
What?
Throw it away.
Durian.
Jared.
No, she is.
No, I
Okay,
I like
she
Jared.
Excuse me, fish boy, could you sit down for a second? Oh, it smells like a supermarket now.
Do it.
Right. So, do you know what to do with this one then? Yeah. You should do this twice. You do, this is the I and this is the or,
Yeah.
and the other way around, the I and the or as well. So you actually have two times. I and or, and then I and or. So the reason we do it the second time is because we can get a critical angle in the second one. We don't get a critical angle in the first one. Yeah? Now this isn't the only way to do this experiment. If you did this experiment in school, you might have done it with the piece of paper on the table, and you have the glass, and you have the laser, and then you use a pencil to draw the laser, and then afterwards you can take the paper and then measure the angles on it. But this one's a little nicer because you can measure the angles as you do the experiment. Technology, exactly right, yeah. Okay, any questions with this one? Right, so this is the first experiment. You need to do this one and write it in your lab notebook. But you don't need to type it, just handwritten. Yes, okay. Now, let's just get rid of this water here. Oh, and was Lee here when I said not to look at the laser in the eye?
No. Why? 700 only.
It's a red light.
Yeah, it's just...
It's good for your eye. But 700. Red
Or
light.
we can do the experiment on your eye.
Don't-
We can explain everything.
Don't trust Jerry. Don't trust Jerry.
But did you say it's harmless until UV?
That's a laser.
Yeah, it's infrared. Was it?
Lasers are a little bit different electromagnetic wave. I can't remember, I have to double check it, but what's interesting about the electromagnetic... Sorry, yes, red is not harmful, right? Agreed? Okay. Is your mobile phone harmful?
No.
No, it's not.
Yeah.
Radio? Radio?
No.
No. Microwave?
No.
No, it's not harmful because it's only harmful at the UV, okay? So microwave is not harmful, agreed? Okay, would you sit in a microwave oven? If I made one big enough, would you sit in a microwave oven?
Yeah.
No, you wouldn't, okay? So, it's harmful not because it's a high frequency and it'll give you cancer. That's not the reason it's harmful. It's harmful for the same reason the microwave is harmful. There's a lot of it's a lot of energy in a small space. It's too much for the eye. Yeah.
So Wi-Fi kill us too.
No. You must understand. Look, okay. If I punch you, that won't kill you. But if I punch you hard enough in a small enough area, that will kill you. But punching generally doesn't kill people. Okay? So the Wi-Fi normally doesn't kill people, but if you made a big enough laptop the size of a building and you put someone right on top of the Wi-Fi, then yeah, that might be harmful because you're going to slowly cook them. Yeah.
Wow.
Yeah. So what if you look at this, you know, you don't want to cook your eyes. right?
Why?
You don't. Eyeballs.
What?
Oh my god.
Don't waste the water.
What is
now.
someone-
Waste the
Yeah.
water.
What do you want to
Water
drink
is
it?
wild. Yes.
I didn't see what Lee did with it. I can't attest to the cleanliness. Don't worry, it didn't land on anyone. It just went into the gutter.
Phase 3.
Okay, so that's the first experiment now. Yes?
So the electric tower kill people?
No, it won't kill you, but if you have it focused in one area,
So it kills you a
yeah,
little bit.
it's like an electromagnetic pressure. Huh?
So
What? You really want to kill people with electromagnetic waves? Okay, next experiment.